Hi Bobcats, this is Miss Lee, and this is our second video on linear relationships. So in our first video, we talked about how to identify independent and dependent variables when given tables, graphs, equations, situations. And now we're going to talk about how to identify if the relationship in tables, graphs, situations, equations are additive or multiplicative relationships. So make sure that you're taking good notes as you're watching the video. Okay, additive and multiplicative relationships. So let's do some discovery. Okay. It says every state has 2 U.S. senators. The number of electoral votes a state has is equal to the total number of U.S. senators and U.S. representatives. Okay, so the number of electoral votes is 2 more than the number of representatives. So we can complete this table. If we have 1 representative, then the total electoral votes will be 2 more than that 1, which would be 3. If we have 2 representatives, then the total electoral votes would be this 2 plus 2 more, which is 4. So if we have 5 representatives, how many total electoral votes will there be? Well, there will be 2 more than the representatives. So 5 plus 2 is 7. It doesn't matter how many representatives you have. To find the total electoral votes, you're always going to add 2. 25 plus 2 more makes 27 electoral votes. 41 plus 2 more makes 43 total electoral votes. So if we describe the rule, we can say that the number of electoral votes is equal to the total representatives plus 2. So that is our rule. This is what we call an additive relationship. And it can be represented by the equation y equals x plus a, where a represents any number. Okay, let's talk about this equation. This is what makes a linear relationship, because it's a relationship between 2 different things. It's a relationship between the independent and the dependent. And so those are represented by x and y, right? We learned that the independent is on the x-axis, the dependent is on the y. So they're represented. We know that the dependent y depends on the x. In order to figure out what y is, you have to know what x is. So that's why our equation always starts with y. You're trying to solve y. What are we going to do to the x so that we can make y? Figure out the dependent. In this case, this is additive. We're going to add a number to x. And that number that we add, we use a to represent that. And remember, any number is called a constant, right? So we're adding a constant to x. We just use a to represent the constant. So if you're going to write an additive relationship, you're going to use y equals x plus a. Then what's really fun about this is you can take that table that we just made over here. 1 representative is 3 electoral votes. Remember, we needed to know the number of representatives, that's your x, in order to figure out the total electoral votes, that's your y. So we can take these x and y values and we can put them in a table over here and graph it. Isn't that exciting? So come over here, if we graph it, it would look like this. Remember, this is your x, the number of representatives. The total electoral votes would be your y. And we've already learned how to graph. This would be your order pair, 1, 3. So we'd move over to 1 on the x, go up to 3 on the y, and then you plot your point. You'll notice if you connect all of your points, what does it make? A straight line, because it is a linear relationship. Now let's try this one. Franny orders 3 DVDs per month from her DVD club. So let's complete the table. In 1 month, how many DVDs does she order? 3. 2 months, how many DVDs would she have ordered? How many total DVDs? 6. After 4 months, or in 4 months, how many total DVDs would she have? 12, right? How did we get that? Because we multiplied by 3. She ordered 3 DVDs per month, and per means to multiply. So we take the 1 month, multiply it by 3, it gives us 3 DVDs. We take the 2 months, multiply it by 3, we get 6 DVDs. We take the 4 months, multiply it by 3, we get 12 DVDs. Now complete the table. Do the same thing. Use the same rule, multiply by 3. We get 39 DVDs. Take the 22, multiply it by 3, we get 66 DVDs. So the rule is that the number of DVDs ordered is equal to the number of months times what? Times the 3. This is what we call a multiplicative relationship, which can be represented by the equation y equals ax, where a represents any number. So remember, this a is your coefficient. It can represent any number. We can multiply x by any number in the equation. Again, the number of months is your independent, that's your x. In order to find the DVDs that were ordered, you need to know how many months she ordered DVDs, right? So the total of DVDs ordered, that's your dependent, your y. So y equals a times x. Then you can do the same thing. You can take your xy values from your table. We can come over here, put it in a chart, and we can graph them, right? Turn it into an ordered pair. This was what the graph would look like. Now, what's really important is to compare these graphs. What differences do you notice about the graphs? Well, some of you might say that the line over here in the graph on the right, the multiplicative graph, is steeper. That's true. Okay. Some of you might say, oh, well, the numbers on their graphs, like the numbers on the x-axis, are different, or the numbers on the y-axis are different. That's true. And then some of you might notice, hey, look, the line on the graph over here on the right, the multiplicative graph, it hits the origin, but it doesn't hit the origin over here on the additive. And that's what I wanted you to notice. Multiplicative graphs go through the origin. Additive graphs do not. So anytime you have a graph and you want to know if it's multiplicative or if it's additive, draw the line, extend it through the origin. Will it go through the origin? If it does, then it's multiplicative. If it does not, then it's not multiplicative, it's additive. So let's try some examples here. We're going to determine if these are additive or multiplicative situations. So we start with the first one. It says Alfonso spends $20 each month to buy a new book. Okay, what do you think? Look for the clue words. It's a situation. Look for the clue words that mean to add or subtract. And subtract is considered an additive, just like division is considered multiplicative. I'm sorry. So look for the clue words. Add, subtract, multiply, or divide. Well, it says each month, doesn't it? So that means it is going to be a multiplicative relationship. So what is the rule? If we're multiplying, what are we multiplying by? By 20, aren't we? Okay, so let's go over here. We said it's additive and we said it's multiplicative. So we learned to write a multiplicative equation. It's going to be y equals ax. Okay, so we're going to replace the number that we're multiplying by for the a in our equation. And we said we're multiplying by 20. So our equation would be y equals, replace the a with 20x. That means to find the dependent, which is what? The total amount of money he spends. Okay, so to find the total amount of money he spends, we're going to multiply 20 by each month, where x represents the number of months. So y equals 20x. So that is multiplicative. Let's come over here to the graph. This one's the easy one. All you have to do is look at what? Does the line go through the origin? Remember, the origin is at 0.00. This one, it does go through the origin, so this one is multiplicative. Okay, let's look at the table. Multiplicative or additive? Well, Here's the total. That's your dependent. Normally, if we were to graph it, we would say this is y. They tell us a different variable. They say use t, and that's fine, t for total. The labor cost, they said to use L, but this is our independent, which would be graphed on the x-axis, right? So let's look at it. How do we turn the 25 into a 55? Can you multiply 25 by a number to make 55? What about 50? How can you turn 50 into 80? Can you multiply 50 by a whole number to make 80? No. So let's try adding. What could you add to 50 to make 80? Well, you could add 30, right? Well, if you do the same thing to the 25 and add 30, does it give you 55? Sure. Come down here to the 100. If I add 30, do I get 130? I sure do. So this is an additive relationship, right? So the equation we would use for the additive would be y equals x plus a, where a represents the number that you're adding each time. So to rewrite it, we would rewrite this as y equals x plus, what were we adding? 30. Okay, coming down here, Dan's Donut Delivery. This is a graph. Okay, so there's not a line. There's some dots plotted, but not a line. So you could actually go and draw a line through the points. Does it go through the origin? No, it does not go through the origin. The origin's down here, the 0, 0. So because it does not go through the origin, this is an additive relationship. Remember, only multiplicative relationships go through the origin. And one more. A website charges a fee of $10 more than the number of songs downloaded. Okay, so let's check it out. Clue words. What tells you to add or to multiply? Well, it says $10 more, so that would mean you would do what? You would add. So we're going to use the y equals x plus a. The variable y and x stays the same, and you replace the a with the number that you're adding, which is 10. So the equation would be y equals x plus 10. Okay, great job, Bobcats.